everyone. I'm Gabriel Broner. Some of you may have met me before. I was with Cray in the 90s, then I was with SGI for a number of years. And as of a month and a half ago, I'm with Rescale doing HPC in the cloud. So I'm going to talk about 25 years, a month and a half, but 25 years of HPC on premises, and a month and a half at a startup doing HPC in the cloud. And startups move very fast. So I'll tell you what I learned in a month and a half and how I'm thinking about HPC and how it's moving forward. So this is the agenda. I'm not going to say too much about the agenda, but I'm going to talk about the evolution, the disruptions that have happened in high-performance computing and what I see in the future. Talk about HPC in the cloud, use cases of HPC in the cloud, what's needed so you can run in the cloud, and how you can incorporate cloud into HPC and how we see the future. It's going to be fast-paced. First, I met some of you here, and here, right? So I joined Cray in 1991, and I work on Unicos and some of those machines. A test for all of you is, do you recognize that guy? Yeah, Seymour Cray. He created those sophisticated systems that we used at the time. But then when I joined, we were using those systems, and we decided to go and build what we call MPPs at the time. Those were single node with a standard processor memory and a high-speed interconnect. Today, we would call those a cluster, an HPC cluster. But at the time, this was an MPP. And I have to tell you, I draw this line here as a disruption because when we were building this, and Jim is standing in the back watching me to keep me honest, because we worked together on that system, and people were looking at that saying, it's not going to be as fast as that other one. But in the end, you've seen what happened with HPC clusters. So when the disruption appears, we all shake a little, think it's not going to happen, and then it happens. Then I was at SGI when at SGI we decided to go from IRIX to Linux, and all the customers were telling me, you're crazy, Gabriel. Linux is a toy operating system. And then here we are, 20 years later, and Linux is the operating system. So, but at the time, it was a bit not comfortable to know that the open source community was going to be developing and fixing things for you, and people felt really uncomfortable. So they were pushing you to stay with IRIX, with AIX, Solaris, whatever the OS was. And this was a special machine, and Rupak, you probably recognize the Columbia system there. That's a machine that sent the shuttle back in space, because at that time we were able to simulate in 2 hours the re-entry after the accident, 2-year stop, and people volunteered their time to build their system at SGI because it was so big that we needed to put it together very fast. This system had its own ASIC, and it was 512 CPUs in one node. Each CPU had one thread, but it was an Intel processor. Our own architecture, designing an ASIC costs about $30 million a year, so it's kind of expensive. And then this is the next machine Rupak has in his facility at NASA Ames, which is, this is the Pleiades machine that is there today, and it has Intel 2 CPU nodes. And if you open the hood of any of the supercomputers today, you're going to find pretty much the same thing. Intel 2 CPU nodes, InfiniBand, different packaging, different cooling, different something else, but they all have moved in this standardization. So all of these changes have happened, and my point is, cloud is appearing in the horizon. It's offering an alternative, and as you Intel people probably know that Intel is selling more processors to the cloud than on premises. That's probably telling us something. And for 25 years, I believe that HPC had to be on premises, but in the last few months, I've been thinking about the challenges and the issues, and that's what I want to relate to you. So what happens with HPC in the cloud? And let's imagine that future. If you're running in the cloud, you have instant access to unlimited resources. So if I need to run a job with as many processors as I want, I can have it in the cloud. I have a choice of architectures. If I have an application that needs CPUs, I can run it on GPUs. But another application that uses CPUs, I can run it on CPUs. One of the big questions I had at SGI from customers is, with CPU, GPUs, KNL, FPGAs, et cetera, what should I buy next? Well, if you're working in the cloud, you run the application on the best possible architecture. In the cloud, you may have applications that are already available in tune, and you pay by the hour. When you do that, okay, I'm going to run this application on this architecture, pay by usage. I run the application on the best architecture, and I run jobs with no wait. So effectively, the idea that I have a $20 million big cray sitting there, that I'm going to have it fully utilized and submit jobs is what happens today. But once you have the cloud, you can run jobs in parallel. You can run one large job if you want to. It doesn't really matter. So you run jobs with no wait, and the engineers are really not constrained by the size of the system. So that is appealing. In what sense it is appealing? You can do faster innovation. If you have an idea, you can go test it. Some of our customers would tell me in the past, somebody shows up with a big job, I ask them, are you going to run this over and over again? And they say, I don't know. Well, they're testing something, and they want to innovate. Then shorter cycles. Everyone doing simulation today tells me their objective is to reduce the cycles. If they reduce the cycles, then they reduce the time to market. They reduce the time to innovation. So it's important. If you're not sitting in a queue, if you can run on the fastest architecture, if you can run as many nodes as you want, you're going to get that. The other thing is immediate provision of variable size and no capital investment. Some people would ask me, the next machine I want OpEx, no CapEx, and that was coming from above to them. The immediate provision is today, if you want a new system, typically 6 to 18 months until you have it installed on premises and running. In the cloud, tomorrow you can have what you want. So system utilization becomes a thing of the past because, who cares? You're using what you need. Job queues, well, there's no queues. You run things instantly. Do you need a scheduler? You probably don't need a scheduler at this point. These things become things of the past. I know I'm being a bit like pushing this, but I've been thinking about this, and when I think about the future may end up looking like that. And if the future looks like that, how do we work from where we are towards that future? Let me say one more thing. People say, HPC in the cloud is expensive. It's more expensive than on premises. One CPU on premises versus one CPU in the cloud more expensive. And I say that's not the right comparison. Let's take an example of a real customer from Rescale, auto manufacturer, that has this workload, which is typical, peaks and valleys, right? And they decided if I buy a system in-house, blue line, it's going to cost me $4 million. It'd be highly utilized. That'd be the typical choice, right? Now, I could buy a system for the peak, but nobody does that because that'll cost me $20 million and be very underutilized. So instead, they decided to use Rescale. When they use Rescale, they don't buy a system in-house. They just get what they need in terms of when they have a higher peak, they get more CPUs and they run that way. The net result is they pay $50 to $100K a month. They run their workload as is with no wait. Think about that, $50 to $100K a month. So if you buy a $4 million system, your depreciation for 3 years would be $111K a month. That's what my budget would get hit with. Now, if I spend with the cloud, it'll be variable spend, $50 to $100K, and I'll have exactly the hardware that is matching that shape. If I have the hardware matching that shape, is if I have the hardware that I need. So in result, what this company did is the cost was equivalent to buying the $4 million system, but the service they got was equivalent to having bought a $20 million system, a system designed for the peaks. They didn't do that. They just used the cloud for their utilization. This is making things worse. Should I buy CPUs, GPUs, or what? Should I split my system half and half CPUs, half GPUs? That's a challenge because having free CPUs doesn't help me to have to run jobs that need GPUs. Or a challenge of what architecture should I buy makes the problem worse of the comparison between on-premises and cloud. Let me give you a few examples of real customers using the cloud today. This is wing design of the Boeing 787. Our two founders were the guys designing the wing of the 787, and they couldn't do it with the in-house system they had. They went off, found as many CPUs as they could, and they ran this for a weekend. And effectively, in 24 hours, they were able to conclude the design. The wing is just one piece. It's lighter by 150 pounds, which means for the airline cost savings of $180 million through the life of the plane. Their impetus in doing that made them found the company Rescale. So this is SpaceX. SpaceX needs to do like 100,000 different simulations before they launch the rocket to understand that they have high probability of succeeding. Well, they use Rescale, they use the cloud to be able to do these 100,000 simulations very quickly, and they have high confidence on running, on launching the rocket, which is really great. Another example, this Formula 1 racing, you heard about the new manufacturing where you have a virtual and a physical parallel worlds, they call digital twins sometimes, in this track. This is Manor Racing, and what they did is they had a cloud simulation of the race in parallel with the actual race, which means they were able to get data from IoT, from the sensors of the car, feed that into the virtual model, and change the strategy of the race. And this is Boom. Some customers are increasing the use of HPC they have today. Some customers are starting with HPC for the first time, like some of you are saying, how do we do that? Well, the cloud is a simple space. Some customers are starting in the cloud. Boom is designing a supersonic plane, a startup totally in the cloud. Not only they designing, but they do flight simulators where the pilot sits, and it's really flying the plane today, which is kind of interesting. So challenges of cloud. Well, you have diverse data centers. In the case of Rescale, it runs on top of Azure, Amazon, etc., and supercomputing centers across the world. You have to make them all seem similar. Applications. One of the things Rescale has done is ported 200 plus applications and tuned them for the different types of systems. So you choose the application to run, it'll tell you this one runs better on GPUs, this one runs better on CPUs. So it gives you all the options, but it'll put ahead the options that make the most sense. So for example, Abacus runs 5 times faster on GPU, so I'll suggest this first, while LSDyna runs better on large memory CPU, will do this first, and this is an example of TPU. So you have what you need. Reliability and security, big challenges. You need to make sure that you're going to put in the cloud is reliably secure, so lots of effort needs to go into that. And usually you need a simple user interface. So in the case of Rescale, this is the interface. You choose the workflow, the hardware you're going to run, how many cores, and it goes. So incorporating cloud in HPC, I've been thinking about this problem for the last month, and I'm going to give you 10 things to do. Why this way? Because cloud is an all or nothing. If you wait for the next RFP 3 years, what's going to happen is you're going to select between Dell and HPE or Cray, or Rescale. You never choose Rescale because it's such a big change in the world. That's a huge disruption. But instead of spending $5 million in 3 years, you can go spend $100K now and start using the cloud. And if you start using the cloud, you're going to learn from it, you're going to evolve, you're going to iterate, and by the time you buy the next system, you know how much cloud, what are the right workloads for the cloud or not. So here's my 10 things proposed. Start testing cloud next week. Don't wait for the next RFP. Start small. Pick a small project, a small group of people that can test cloud, that benefit from cloud HPC. Test the future experience. Think about that world I described earlier and make sure you test that. Don't assume, I think cloud bursting is a nice idea, but I'm not sure that's what you want. You want to test the future and you want to start moving in that direction. So pick a few projects, move them to the cloud, and start using the cloud interface right away. So use the cloud directly. Don't try to solve all the problems before you start. Security, high-speed links, and everything. You're never going to start. So effectively, go start right away. Run once, learn from experience, iterate, address the uncovered issues, and then select more projects of bigger scope, add more people, keep iterating, and that's going to be a successful plan as opposed to do an all or nothing cloud. So I wrote a blog. You can go to it in blogrescale.com. If you like this topic, I call it Cloud, the Next Disruption in HPC. And Rich was gentle enough to create an article too from me. And I mean, what he wrote there is actually he extracted the part of my writing, which is basically like previous disruptions that I talked about. This gets us out of control, out of the comfort zone, but the effect of price, flexibility to dynamically change system size, choose the best architecture, availability of applications, select system costs based on the needs of a particular workload, and the ability to provision and run immediately will prove very attractive, and that's true. With about 14 seconds on my timer, I'm finishing. Thanks, everyone.
Gabriel.
This one there.
So if I understand you right, you're in a sense reselling cloud cycles, but you package them for end users to help them find the right resource at the right time?
Yeah, so you're more interested, what's the business model? So as a user from a user point of view, you go select you want to run ANSYS, it'll give you the best possible architecture for the job, you're just running. So from an engineer working on this platform, it's very easy to run your job running in the cloud. From a business model point of view, we have a markup over what you'd pay Amazon, but we have a contract with Amazon and we get better prices and things like that. So we make money as you use the system.
And you vend the cycles from Amazon, from Google,
we pay
and
to Amazon, we pay to Google, we pay to Microsoft Azure, or to supercomputing centers like Ohio Supercomputing. Supercomputer is there.
Okay, great. Thank you.
You're welcome. There's a question in the back.
Thanks for your presentation. It's kind of a follow-up question. I think you might have answered some of it, but my question is basically, why do I go to you? Why don't I just go to AWS and do it in AWS? What's the...
Two reasons. One, you can go to AWS, but they'll give you CPUs. That's it. And then you have to do everything else. You come to us and you say, I want to run this application. It's going to be the optimized version of this application to run on AWS, etc. Second thing, we are multi-cloud. So if the best option for you is to run on Amazon, you run on Amazon. But if the best option is to use InfiniBand, we'll give you the Azure InfiniBand interconnected nodes. And if the best option is bare metal, you're going to get perhaps Ohio Supercomputing bare metal option. So multi-cloud, and it's at the higher level of the application, not here's a bunch of CPUs.
So, I mean, that's a great answer, but my IT department took about 2 years to really allow us to run on AWS.
We can limit it to AWS if you want to do that.
And so, you know, so if I go to you, right, and I run on Rescale, and you don't, you know, you will choose Azure, you know, whatever. How do the IT departments do that?
We have admin controls. So we can set your company or your group to only use AWS or internal systems. This same interface we offer to run in the cloud, we can use it to pull your internal systems. So you can have one interface to submit jobs to, in your case, internal systems or AWS, you don't get IT upset. Other people may want to include Azure. You can also bring your own contracts like AWS or Azure Enterprise Agreements, and we'll honor those. Make sense?
Gabriel, I have a question for you.
Yeah.
So you have negotiated software licenses with all the third-party software companies?
The software vendors either offer by the usage, and you pay by usage, or you can bring your own license. We allow that too. So if you have a license for LS-DYNA, you can bring it in and run LS-DYNA using your own license.
But you also have the
We
licenses.
also have for many vendors that have offer by the usage, we offer that. There's a question behind
That
you.
alone is a big advantage.
There's a question behind you.
Forgive me if I ask a question that isn't quite understanding your business model, because I'm just sort of learning it. But if a user let's say a company wants access to high performance computing, they can come to you and you have a list of resources that they can access. Is that correct?
Correct.
Correct. How do you handle export controls?
Oh,
So let's say a university is in your list, Ohio, you mentioned Ohio.
Yeah.
How do you make sure that someone isn't running something that's prohibited or controlled in a way that Ohio can't handle? Or do you dump that onto Ohio as their responsibility?
So first, we have by projects, you can have things like ITAR control environments, or we have also the possibility to run European jobs only in Europe. So all these things can be set via administrative ways. So people won't see your data. Data is encrypted. I mean, I don't want to give a pitch, but there's enough going on that enables all of that. Makes sense?
I was just wondering actually the opposite.
Yeah.
How do you make sure that something, I can understand how someone wants security for their data, and
Yeah.
you can provide that. How do you make sure that somebody doesn't surreptitiously come in and start running stuff that is a no-no? You know,
Right.
they're just sneaking around
Well,
and trying to.
I'll give you all the details after that, but
Okay.
effectively there's security controls that won't allow you to do that. Exactly, yeah. I'm sorry.
I was a little bit confused by what you said. You don't need schedulers on the cloud or something along those lines that you
Yeah,
said.
isn't that
you know?
controversial? Yeah.
Yeah.
We lived
and-
for 30 years with schedulers, and when I think about the future, I think maybe you don't need one, but go ahead, yeah.
Yeah, so what I'm thinking is, I might have a workflow where I might want to schedule something on, the GPU in Azure, and maybe I want to do something in Google or something like that, right? And
Sure.
what I'm looking at Rescale is it more of a job assigner than a scheduler?
You can
do
draw
some
your
complex
complete
workflows?
workflow in Azure and do it that way.
Okay.
So in the case of the scheduler, to manage your job, you can do that also with Rescale. But you can do it directly with the Rescale interface. When I say you don't need a scheduler, I say you have no wait. So if I need 1,000 CPUs, I get them now, so there's no queue. So the queue management aspect of the scheduler is what I think
I see.
we won't need anymore.
Okay, you're assuming that, the cloud gives you infinite resources or something.
Yeah, there's always
Right.
something
Which is never
available.
true, but that's I get the point.
Pretty true, yeah, pretty true.